The box plot shows information about the length of time in minutes some people waited to see a doctor at a hospital on Monday. And in part A, we need to work out the interquartile range of the information in the box plot. So this line here on the box plot represents the upper quartile, and this line here on the box plot represents the lower quartile. So if we want to work out the interquartile range, which I'm just going to say IQR, we need to take the upper quartile. So upper quartile, I'm going to subtract the lower quartile. So for our case, we're going to have the interquartile range. And let's see what upper quartile we've got. So we just quickly need to work out the scale of our diagram here so we can work out what measurements the lines represent. So I'm going to take this as an example. We're going from 80 to 120. Halfway between 80 and 120 is this line here, because you can see it's slightly more bolded. And halfway between that, we're going to have 100. So now let's look at this range. We're going from 80 to 100. And how many little boxes do we have? Well, we've got 1, 2, 3, 4, 5. So going between 80 and 100, the difference is 20. So that covers 5 boxes. So the range of 20 is covered by the 5 little boxes. So one box represents, so we're going to do 20, which is the total, divided by 5, which equals 4. So every time we move along one little box, we're moving along 4. And that should help us when we work out the lower quartile and the upper quartile. So we're going from 160 here up to 200 here. So here must be 180. And each of these little boxes represents 4. So this line here is 2 along from 180. So we've got 184, 188. The upper quartile is at 188. Now let's do the same for the lower quartile. So starting at 40, the boxes again we're going to represent 4. So we're going to go to 44, 48. And then this line here for the lower quartile is halfway within this little box here. So we're at 48 here, but instead of going all the way 4 more to the next box, we're only going to go 2, so halfway. So from 48, 50. So the interquartile range, we're going to have the upper quartile, so 188, subtracting the lower quartile of 50, giving an interquartile range of 138. So the answer is 138 minutes. So we get 1 mark here for either working out the upper quartile or the lower quartile. Then we get a second mark for working out the interquartile range itself, so getting 138. Now for part B, Becky says that 50% of people waited at least 2 hours. And is Becky correct? We need to explain why. Well, again, we're going to take a look at our box plot. And we need to see where the median is. So the median is represented by this line here. And that's at the 120 minutes mark. So the median is 120 minutes, or if you say that in hours, that's 2 hours. So this means that 50% of the people waited more than 2 hours, and 50% of the people waited less than 2 hours. If we look at the statement, Becky said that 50% of the people waited at least 2 hours. So yeah, Becky's correct, because the median is at 2 hours. So that means that 50% of the people waited 2 hours or more. Because look at the box plot, we can see from the median at 2 hours or 120 minutes. And it spans all the way up to the highest value at 200. So 50% of the people are within that range there. So it follows that Becky's correct. They waited for at least 2 hours. And if we get a statement, something like that, we get 1 mark. The table gives us information about the length of time in minutes some people waited to see a doctor at the same hospital on Tuesday. Becky was asked to compare the distribution of lengths of times people waited on Monday with the distribution of lengths of times people waited on Tuesday. She wrote people had to wait longer on Tuesday than on Monday, and give one reason why Becky might be wrong. So now when we looked at the box plot before, which is their data for Monday in the hospital, we can see that the longest time was at 200. So we can see here on Tuesday, the longest time is actually higher than that, 210. So on the face of it, it might look like on Tuesday people had to wait longer. However, that could be one anomaly. That could be one time that this person had to wait to 210. And the rest of the time, everyone had to wait a really short amount of time. So we need to look at the distribution as a whole. A good thing to check is the median. So now looking back from our previous part on the box plot, we know that the median for Monday, so in part A, is 120. However, here the median for Tuesday is lower. It's only 100. So we can't be for sure, but that's a good indication that Becky may be wrong, and the wait times could have been less on Tuesday than Monday. So I've written as my answer, the median is lower on Tuesday, so 100 compared to Monday, 120, which suggests that Becky could be wrong. For a statement, something along those lines, giving a reason, we get 1 mark.